This is part 3 in a series of videos in which I'm working on this Cromemco System3. I'm trying to restore and repair it, get it fully functional. I don't own this, I'm repairing it for somebody else. And in the previous video I tested the power supply, carried out a few minor repairs, and the power supply now seems to be working fine. The next step is to finish stripping down the chassis, at least as far as I'm going to take it. It's in very good condition, so I don't need to completely dismantle it. But what I'll do now is take off the door and then we can remove the cards from the electronics rack. So it's very straightforward to dismantle these. So there's a few screws I need to take out and one connector. It's quite difficult filming this because it is a very large unit, so bear with me if you can't quite see what's going on. I'll try and describe it as best I can. But as I say, the next step is to try and clean it. It's in good condition but very dusty and dirty inside, so that's the next step. And of course I don't want to power it up with the cards in initially. I want to make sure that all the supplies are going to the points that they should be before we start trying to apply power to the boards. Also I'll take the covers off the back of the front panel, the door, and we'll look in there to make sure there's no debris or anything in there that we need to sort out before we start trying to apply power. So I'll get this door off and then we'll have a look inside the electronics rack. So I've taken off the door, remove the screws from this rear cover so we can lift that out of the way, and this gives us access to the main switches for the floppy drives. So what I'll do is I'll spray some deoxit in these just to make sure the contacts are nice and clean, and then I'll put a meter across and make sure these all operate. The two on the left here are not actually in use, but I'll test those anyway. The other thing I'll do is I'll take this board off and clean the other side and lubricate the key switch. It is a bit stiff at the moment. That's fairly dull, so I won't bother filming that. And then what I'll do is I'll clean all this out. There's a lot of dirt and debris in here. Give it all a good clean. Again, lubricate the inside of the catch. That's a bit sticky as well. You see it's not returning properly. So that's just a few simple mechanical things that need sorting out. But what we'll do now is look inside the electronics box, pull the cards that are in there, and see what's actually installed in this machine. Okay, so looking back at the main chassis, we've got the electronics box here, and it just slides out, and of course without the power supply counterbalancing this, the whole thing's going to tip forward when we pull it out. But if I pull it out far enough, it shouldn't really matter. Okay, so I'll just move the camera down a bit. Right, what we have here is a very nice system, well over engineered. These are really nice to work on because it's so accessible, and with this thing slid all the way out, you can see it slides out a long way, so you've got a good 4 or 5 inches once you've slid this right the way out. I'm not going to take the ribbon cables out, they are all in good condition. I don't think this thing's had a lot of use in terms of this being slid in and out. What you sometimes find is these have dried out and start to crack. The only thing with these, it's best not to use this first slot, otherwise it tends to foul on the first cables and can eat its way through the insulation and cause problems. So only 4 cards in this machine, so we'll pull them all out and see what we've got. So first thing is to get this out of the way. No screws to take out, we just have this bolt action cover. So again, very nice system, makes life very easy. And then the next thing to do is to lift out the cards. You can just pull them out, but I've got a special tool I use for this sort of thing. Okay, so as you can see, this is the ZPU card, so this is the Z80 processor card. It is an S100 bus on this, so it's very easy to fault find on because we have all the usual connections going to the same pins you'd expect on any other S100 system. So that's the first card. So we'll come back and look at these cards in more detail in a future video. So we'll look at these one at a time as we need to refit them and test them. Okay, I'll just lower the light so hopefully you can see inside this a bit better. Okay, and we'll remove the next card. And as you can see, this is the 64K memory card. So very typical of S100 memory cards. You can see there's been quite a bit of heat building up on these two dropper resistors, but you'll find that on pretty much all of these cards. These draw a lot of power and they do get quite hot around the power supply, so that's not that unusual. So these cards are based on 416 DRAMs, and as I say, fairly typical of an S100 memory card. So on to the next card. Okay, the next card is the floppy drive controller card, so we'll get that unplugged, get it popped out. And so we can see this is just a standard floppy drive controller card. Okay, and the last card is the parallel interface card. So again, we'll just unplug the in-out cable from that and we'll pop the card out. And very straightforward card. This is just really a series of latches, and again we'll have a look at this in a later video, but it's a very simple card. And if you do get issues with these, they're quite easy to sort out. One thing that's very nice with systems like this is you've probably noticed already that every single IC is in a socket, and that's on all the cards, and that does make them extremely nice to work on. You don't have issues trying to desolder and possibly damaging the board. One other thing you tend to notice with systems like this is how few bodge components there are on bodge wires. There are a few, but very few, and on this card there's only one. I think that I saw 2 wires on one of the other ones, and they did make an extremely good job of designing these, and whoever was responsible for the project, I just don't think they tolerated bodges. Most machines of the era have numerous wires on the backs of the boards, but these are very nice in terms of everything seems to work the way it's supposed to. Okay, I'll just lower the camera and move the lights around so you can see inside the electronics box, but all that's really left in there is the large backplane. Okay, so as you can see, it's just a 21 slot backplane. Unlike other systems that used these S100 buses, this particular board does have a ground plane on it, so it is very well behaved in terms of these S100 backplanes. On some systems you get a lot of noise on the backplanes and all sorts of issues depending on where you install the cards. This has got a very nice balanced backplane, so I don't expect we'll get any issues with this. In addition to that, you'll notice that every single, or rather every other slot has got a screw. That's not just for support, they are grounding screws as well, so they're both at the top and the bottom, so the entire backplane is very nicely grounded, and it does make it behave very nicely. And because there is a proper ground plane, it means that the signals on the backplane are usually very clean. Another very nice thing with this backplane is every single pin is numbered. If you're used to working on S100 systems, you've no doubt, like me, spent a lot of time counting pins, and it does make the process of fault finding very tedious. Whereas when they're numbered like this, it just it's a small thing, but it does save a huge amount of time. One other thing is they used very nice sockets on these, so again, unlike a lot of systems when the backplane connectors can be unreliable, on these they're very nice and very rare to get problems with these connectors. So you can see that adding new cards, taking cards out, testing them should all be very straightforward. So next step in this particular job is to take this over to the workshop, give it a really good clean, and then what I'll do is we'll buzz through all the power connections. Once we're happy with that, we'll refit the power supply, and then we'll check that all the supplies on the backplane are correct. Okay, so I've given the chassis a really good clean, tested the backplane as best I can, and it seems that all the connections are as they should be. So we've got the backplane going through across to all the edge connectors. The ribbon cables also test out fine. I didn't show that on camera, it's obviously a very tedious thing to do, but it does appear as if though it's all connected. There's absolutely no sign of corrosion on this. It's in really good condition. I've also cleaned up the door, tested the mode switch, adjusted the catch. It was actually just bent, so that's why it wasn't returning properly. And the other thing that probably doesn't really show up on camera is this was absolutely filthy. So I've given it a really good clean. Let's move the camera down. And it has come up really nice and clean. There are very few marks on this, a couple of very minor scratches. I've tested the switches on here as well, and it's come up like new, so it's been very well looked after throughout its life, so hopefully this will come up as quite a nice machine. So the next thing I want to do is get the power supply fitted back into the main chassis, so that just bolts onto the rear. I'll get that bolted in place. Unfortunately I can't really film it, it's a bit too big and bulky to be able to work around the camera, but I'll get it bolted in place and then we'll have a quick look at that, and then the next step will of course be to power it up and see if we get the power going through to the backplane. Okay, I've got the power supply bolted back onto the chassis. I've reconnected all the main power connectors going through to the electronics box. It's a bit of a fiddle down here. There's not a lot of extra wire, so I've made sure these are all properly tidied up, re-cable tied them as they were when I took it off. And the next thing I need to do is fit the D connectors that I took off the rear panel. Doesn't really matter where these go, but I'll put them back where I got them from. There's only two, so I'll get those fitted, and then we can fit the remaining power supply board. Okay, so I fitted the two D-type connectors back to the rear panel. I've put them back where they were when I got the machine, and I've been careful to make sure that I get the routing of the cables back as it was when I took them out. It is very important to get the routing of these cables correct, because otherwise when the electronics box is slid in, it can of course damage the cables. Someone mentioned in one of the comments that there was a label up here that had a date of 1974. It's not actually a date, this is just an inspection sticker, so it actually says 1774, and there's another one on the bottom of the rear panel that says 1775, so I think they were just inspection marks as part of the build process. You can see here that there's another one that says 1775 as well. I thought it was a date when I first saw it as well, but it is not. So I have had a look at all the ICs on the main boards, and as far as I can tell, this particular machine was manufactured in 1979. And that makes sense. That's about the period when these were being produced. They were released at the end of 78, beginning of 79, and so obviously that can't be a manufacturing date. Okay, so next step is to get the small control board and floppy drive power supply bolted in place. So that goes over here. I get this bolted in, and what we can do then is power up the machine and see if it still works. I'll give this a good clean first. You can see it's a bit on the dirty side, so I'll give this a good clean. I'll replace the tantalum cap that's on the back, get it bolted back in place and reconnected, and then we'll power it up and see if we're getting anything going through to the backplane. Okay, I've got the control board reinstalled, I've got it connected. The front panel's not fitted to the machine yet, so there's no point me reconnecting this control cable. So I've left the diode in to fool this board into thinking the power key is in the on position, and as before that will force the supply to come up, and hopefully it will power up and we'll be able to test the supply at the backplane. Got it hooked up to the auto transformer, so I'll power it up. I have checked all the connections several times to make sure I've got them right, so we'll power it up and we shouldn't see any smoke or anything untoward happening. Okay, the fan has started up. Now I've got the auto transformer turned down to just over 200 volts. I'm using the mains cable that came with the unit, and so it's passing through the filter I was talking about. And they tend to be fine in the US, the 120 volts, but as I said, in the UK they do have a tendency to fail very quickly if they haven't been used for a long time, so I'm being fairly cautious with that. So the next thing to do is I'll move the camera, we'll get the multimeter, and we'll see if we're getting any power at the backplane. Currently the the main supply is showing 0.27 amps, so that's well within what we'd expect to see with it in this mode. So I'll just move the camera across. We'll get the multimeter, and I'll try and put it somewhere where you can see it. Okay, well, hopefully you can see that. I'll connect the ground lead to ground on the main smoothing capacitor, so that's our master ground, and now we'll try measuring the voltages on the backplane. So the first one should be minus about 18 volts, so minus 18.9, bear in mind these are unloaded, and then we should have the plus 18, which should be effectively the mirror image of the minus supply, 18.9, which is fine, and then we should have the raw 5 volt, which will be up around 9.5 volts with no load on it, and it is 9.5 volts. So that's all looking fine, all the connections are correct, the board's powering up as it should do. What I can do now is go through and test the other supplies on this particular board. This is the floppy drive supply, so there are other supplies on here, and also these should be regulated. So I'll move this across so hopefully you can see it's a bit better. Hoping that's coming up on the camera. So we should have 5 volts on there, which we do. Or 9.5, 24. So the floppy drives require a few different supplies. Firstly, they need mains to drive their main drive motor, 5 volts for the logic, 9 volt for the amplifiers, 24 volts for all the steppers and the higher voltage components on the floppy drive, same as a standard floppy drive. These are all ground, and then finally we have minus 5 volts at the end, which is showing fine. We only use one of these, but I might as well test both of them while we're here, and these should be exactly the same. And that's fine. So this board is indeed working fine. We're getting the plus minus supplies, the 24 volt rail for the floppy drives, and it looks like this board is running exactly as it should. The connections through to the backplane are all fine. I've already connected the interconnections and buzzed them out to make sure that the supplies are all going to the pins they're supposed to, and that we're getting continuity right the way across the backplane. So at the moment the chassis seems to be behaving itself. The next thing I'll do is put the front door back on, reconnect the control ribbon cable, and see if it still powers up the way it should do. Okay, so I've refitted the front panel, adjusted the hinges, I've made sure that the ribbon cable is plugged back in correctly, and I've already tested the other switches and the control switch on the front panel. So we can close this up, and in theory we should now be able to use the front panel key to power up the machine. I've also adjusted the catch on the door as well to make sure that it operates correctly. So as you can see, it looks quite smart now. It's been cleaned up, and we'll try and power it up. So I'll turn the mains power on. Nothing should happen at this point because the key on the front panel is in the off position. There is a main switch on the back as well, which I have in the on position. So we'll go to the front panel. You can see there's no power on the supply. I'll turn the key to the on position. The fan started up, and indeed we do have power coming from the supply, so it's powered up. We're drawing the same current we were before, and it should obviously go off if we turn the key back to the off position. And of course we have the power light on the front now working as well. So these other switches won't do anything. They're not connected to anything at the moment. We've got all the ribbon cables unplugged. So we should be able to turn this off with the key, which we can. Okay, so the chassis is all nice and clean. It's been tested, a few minor repairs, but nothing much. And what we can do now is start to look at the actual electronics cards. So we'll do that in the next video. We'll start off with the processor card, of course, and then work our way through and try and get to the point where it's trying to boot from the floppy drive. And at that point we'll get the floppy drive back on the bench and go through that. And refurbish it and carry out any repairs that we need to. Okay, comments welcome. As I said before, if you've had one of these and have any interesting stories about them, then please leave a comment.